Part of your success in Success Criteria 5.1 in interpreting chemical equations is understanding how to name a chemical compound with only utilizing its formula, and also translating a chemical name into its formula. These are skills that we learned last semester, but we are in dire need of review. So let's practice first going from name to formula. This is on the first page of your review sheet. If I have an ionic compound, because there are only two types, they're ionic and covalent, I'm going to have a metal, which lives on the left side of the periodic table, and it's going to be bonded to a nonmetal, and nonmetals live on the right side of the periodic table. The other type of compound are covalent compounds. And covalent compounds are made up of two nonmetals. So two elements from the right side of the periodic table. And based on which type of compound it is, it has a different set of nomenclature or naming rules. So in my first example, I look at the first element, which is potassium. And after looking at my periodic table, I see that potassium is on the left side of the periodic table, which means it's a metal. So potassium is a metal, and because it's a metal, I know I have an ionic compound. So from going from name to formula, I'm going to look at the first element, and I'm going to write its symbol, but also look up its oxidation number, which I should have written on the top of each group on my pink periodic table. Because potassium is in the first column, it has a charge of +1. Bromide, so that ID ending signifies that it's a front side element, meaning it's on the periodic table. So if I look at the root of the word brome, that's bromine, or Br. I also have to look up the oxidation number for bromine, which is -1. So because potassium and bromine have the same number but opposite charges, that means I only need one of each, so my formula is KBr. My second example, potassium sulfite, I ask myself the same first question. Is potassium a metal or a nonmetal? And after looking at my periodic table, I see that potassium is on the left side, so it's a metal. So because I have a metal as part of my compound, it's ionic. And I follow a similar step as before. I have the symbol with its oxidation number. But the anion ends in ITE. And I have to remember that if I end in ITE or ATE, that it's a backside element, or a polyatomic ion. So I'll have to flip my pink periodic table over and scan the list for the word sulfite with ITE. And the formula for sulfite is SO3, and the charge is -2. So because these are not the same number with opposite charges, I'm going to have to crisscross charges. So I'm going to bring down this 1, and then I'll pull down this 2. So my chemical formula is K2, and because I pulled sulfite from the back side of the periodic table, I could put it in parentheses, and then the 1 would technically go on the outside. In my next example, I have iron. Now I have a Roman numeral 3 oxide. My first question is the same as the last two. Is iron a metal or a nonmetal? Well, after looking at my periodic table, it's in the middle, but that still counts as the left side, so it's a metal, which means that this compound is ionic. So I'm going to write the symbol for iron, which is Fe, but then there really is no pattern to the middle of the periodic table, which is why I have to give you the charge as a Roman numeral. So 3 lines next to each other stands for 3, so this is iron plus 3. Oxide, because that ID ending means it's a front side element on the periodic table, which means I have to look at the oxidation number I recorded at the top of the group. So oxygen has an oxidation number of -2. Because these are not the same number with opposite charges, I have to crisscross these down, so this formula becomes Fe2O3. In my last example from name to formula, I still ask myself the same first question. Is this first element, carbon, a metal or a nonmetal? After looking at my periodic table, I see that carbon is on the right side, so carbon is a nonmetal. So because I'm beginning with a nonmetal, that means I have a covalent compound. When I have covalent compounds, I'm working with prefixes, and I see one here. So now I have to remember not only the prefixes, but also what number they represent. Because there's no prefix in front of the word carbon, that means I only have one of them, so I just write the symbol. But tetra stands for 4, and fluoride stands for fluorine. So it means I have 4 fluorines. But the symbol comes first, and then the number comes after. So on the second page of your nomenclature review, you'll see that we're going the opposite way, from formula to name. And we'll go through these examples together. Regardless of which direction we're going in, either name to formula or formula to name, we always ask ourselves the same first question, which is my first element a metal or a nonmetal? So after looking at my periodic table, magnesium, or Mg, is on the left side, so it's a metal, which means I have an ionic compound. So according to the rules that are at the top of my sheet, if I have an ionic compound, I just write out the full name of the first element. But for the anion, because it's only one letter long, which means it's a front side element, it's on the periodic table, I know it's sulfur, but I have to change the ending to IDE. In my second example, I have a letter K with CN in parentheses. Again, I ask myself the same first question, is my first element, which in this case is potassium, a metal or a nonmetal? So K stands for potassium, and it's on the left side, so it's a metal. According to my rules, I just write the full name of the first element. But now, CN is multiple capital letters, and I put it in parentheses to make it easier to identify. So it's a backside polyatomic ion. So now I need to flip my pink periodic table to the polyatomic ions list, and I need to scan the list for CN. And once I find it, I see that the name is cyanide. Now you might be thinking, hey, wait a minute. You told me that anything with IDE is the front side. Well, there are some exceptions that we have to remember from last unit. So like cyanide and hydroxide are very common. Our third example follows the same pattern as the first sheet, where we still ask ourselves the same first question. Is copper, my first element, a metal or a nonmetal? And after looking at my periodic table, copper lives in the middle of the periodic table, so it's a metal. So I'm going to start with writing the full name of the first element. Now, because it lives in the transition metals, I have to be wary of determining the charge, so I also know I'm going to need a set of parentheses in which I'll put Roman numerals in just a few moments. The anion, S, we've seen before, because it's a front side element, we know we must end in IDE. In order to figure out the Roman numeral, I like to translate all of my transition metal compounds into a picture, and I draw them into a box. Because a box has equal sides, just like an ionic compound is neutral, the positive and negative charges have to be the same. So my positive charge has to be the same as my negative charge, which is going to be indicated by height. So in my formula, I don't see any subscripts, which means I have one atom of each element. And in order to figure out the charge on copper, I have to look up the charge on sulfur. So after looking at the front side of my periodic table, I see that the oxidation number for sulfur is -2. So because I have only one atom, and the charge is -2, the overall negative charge is -2. Because the charges for an ionic compound have to be equal and opposite in order for it to be neutral, I know that all of the positive charge has to be +2. But because there's no subscript here, I know I only have one atom. So +2 divided by the one atom means that this atom has a +2 charge. So because the charge is +2, I translate that into the Roman numeral for 2, which is just 2 lines. In our last example, from going from formula to name, I still ask myself the same first question, and that is carbon, my first element, a metal or a nonmetal? And after looking at my periodic table, I see that carbon is on the right-hand side, which means that I am dealing with a covalent compound. These other two were ionic. So because I'm dealing with a covalent compound, I have to remember my prefixes. So I only have one carbon, but because it's the first element, it's just going to be carbon. And then with the O, there's one O, but now I need a prefix, and the prefix for one is mono, and the name for the oxygen ion is oxide. So carbon monoxide is technically the right answer, but we're always going to drop a double vowel to make it sound a little bit more professional. So at this point, you should put your Chromebook away and attempt the rest of the nomenclature review without Googling the answers. You will have a short assessment on nomenclature in the next class. If you have any questions, always feel free to message me on Remind or email me.